went to a free session in the library. Free class on quilling. Quilling? Google, what is quilling? And it's the art of filigree paper. So you take little strips of paper and you coil them into cool little shapes and you glue them together and you make little things like greeting cards or decorations, that sort of thing. I'd actually seen it before. I just didn't know that's what it was called. The point of this story is I'm making Valentine's Day cards and I got my little heart things and I want to glue them to the card. So I squirted a bunch of glue onto the plastic wrap and then I spread it out till it was evenly diffused. And then I could take my little hearts and stick them in the glue and then stick them on the card. We'll see what my family thinks. Just mailed them yesterday. That's what they think. All right, how fast diffusion occurs depends on these factors. First of all, how big is the concentration gradient? If I were to drop a bottle of perfume over here, would it move faster or slower than if I had just squirted it a little? It would move faster.
Oh wait, what?
What'd you say? If I had a huge pile of perfume, it would move faster across this room.
Oh.
All right, this is, we're going to use these principles when we get to the lungs. Get to chapter 16, we're still talking about diffusion. Talking in the kidneys, we're going to talk about diffusion. That's why we have to understand diffusion. All right, how permeable is the membrane? So is the membrane that we're going across, we're bringing it across a biological membrane, is it permeable to that thing? If it's really permeable, that thing will move quickly. If it's not so permeable, it will move slowly. Temperature, the higher the temperature, the faster it moves because molecules are moving faster. All right, this last one. This one is important from a nursing standpoint, surface area. The alveoli in the lungs normally have lots and lots of surface area. Of course, that's going in, so we have lots of alveoli. This is like a big grape thing, if you remember that from anatomy. Lots and lots of surface area for diffusion of gases, oxygen and carbon dioxide exchange. The condition that's called COPD, chronic obstructive pulmonary disease or disorder, that causes loss of surface area. So the alveoli are just kind of big floppy bags. Surface area has decreased. So gas exchange does not occur as fast. And so you have seen these people, this is the end result of cigarette smoking, Teresa. So all the alveoli are gone, the surface area is gone, so now they are already short of breath because they can't move carbon dioxide, oxygen as fast. There's a disease called Crohn's disease, which is an inflammatory process that causes the lining of the small intestine to strip off. So now we no longer have microvilli, and we have this. We have decreased surface area, so we have decreased absorption of nutrients. Okay, so diffusion is a characteristic of molecules to go from high concentration to low concentration until both sides are even. This is from your textbook. This is a membrane that is permeable to these little black dots, whatever these little black dots are. So it's permeable to the little black dots. So the little black dots are going to go from high concentration to low concentration until they're even. As long as this membrane is permeable to the little black dots. Now notice there's a little bit of movement to the left, but the bulk of movement is to the right. And then these dots just move freely back and forth, but there's no net movement one way or the other once they're at equilibrium. Equilibrium means they're equal on both sides.